Hi. So, what we're going to look at in this video is we're going to start looking at being able to calculate the length of a side of a right-angled triangle using trigonometry. Okay? So, in a previous video, we've learnt about SOHCAHTOA. So, just as a wee reminder, I'm going to write it up in the top right. Okay? So, hopefully, remember that SOHCAHTOA is a mnemonic that allows us to remember that sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and TOA equals tan equals opposite over adjacent. Okay? So there's three different variations of this, and you can see that there's three examples up on the board. So you can probably guess what's happening. Some people teach this where they just learn about sine, and then they just learn about cos, and then they just learn about tan. I'm not sure if that's really necessary because the method for each of these is identical. The challenge is recognizing whether or not we're using sine, cosine, or tan. But hopefully we've learned this. So we look at example 1 and considering which angle we've got and remembering how we've named the sides of the triangle. Okay, so we're going to tick off what we've got. Tick off what we've got and also what we want, because it's dependent on the angle and it's dependent on the side of the triangle we want, and I want x. So hopefully you can remember that that x is opposite the 23, so I want the opposite. And I've also got the hypotenuse, which is the longest side, so let's tick that as well. So which ratio are we going to use? Well, there's two ticks on so that means that we're going to use sine equals opposite over hypotenuse. So now what do? We know that the angle is 23, and we know that opposite is x, and the hypotenuse is opposite is x and the hypotenuse is 12. I'm going to use a different letter. So let's say that A stands for angle. That hopefully makes it less confusing. Sine of the angle is equal to opposite over the hypotenuse. Okay, so let's substitute in what we know. We know the angle is 23, we know the opposite is x, and we know the hypotenuse is 12. So we get sine of 23 equals x over 12. Now I want to set this up so I can put it all into my calculator all at once. Something on the left hand side equals x divided by 12. Okay? So how will I get this into just being able to put into a calculator all at once? I can rearrange that equation to be x equals by just multiplying both sides by 12. So essentially I'm bringing the 12 up to the left hand side. Okay? And then, just for niceness, I'm going to rewrite it. We don't need to write the multiplication sign between the number and sine because it's unnecessary. We know that means multiplication. So x equals 12 times sine of 23. And then you check your calculator, you should be able to see that there's a sine button there, and you're just going to do 12 times sine 23. And there I've calculated that it's going to be 4.7 meters. So I've rounded it to one decimal place. Okay? So go through the steps, check which ratio we're dealing with, substitute in, rearrange, solve. It's a lot of work, but we're going to do loads of them and we'll get them, it'll be engraved in your memory in no time. Okay? So let's look at example 2. Hopefully what you can do is, before I even say it, is because I don't really want us to be relying on SOHCAHTOA as a crutch. I want us to be able to look at that example eventually and be like, I know what we're dealing with, okay? Look at the angle, we've got the hypotenuse, and we want this side that's next to the angle, and another word for next is adjacent, okay? So the ratio that we're using is going to be cos. And we remember that cos equals adjacent over hypotenuse. And there, I've cut this light working down to almost nothing already, okay? Now all we need to do to get the final answer is multiply by the 7.8. Put it into a calculator, we get 4.908 recurring decimal, and then we get 4.9 centimetres. Okay? Last one. You can really work out what's going to happen. I've done sine, I've done cos. What's realistically going to happen is going to be tan, but I'll show you why. Look at the angle. We want the opposite, and we've got the adjacent. We've got nothing to do with the hypotenuse. Your first hint that it's going to be tan is you've got nothing to do with the hypotenuse. You neither want it nor you've got it. Okay? So that suggests straight away you've got tan. Okay, which is tan of the angle equals opposite over adjacent. So we had tan equals opposite over adjacent, the angle is 32, so we get tan 32 equals x, the opposite side, over the adjacent 3.2. Bring in the 3.2 up, we get x equals to 3.2 times tan 32, put that into a calculator, we get 1.999, which then rounds to 2.0 to 1 decimal place. So, the method for each of these is exactly the same. The challenge is recognising the sides that we've got, and whether we're using sine, cosine, or tan. Okay? I full belief that you'll be able to do this. Okay? So that was solving for one of the sides in the right angled with right angled trigonometry. Okay?